Hello everyone. So welcome to this lecture on numerical integration. Okay. So before we discuss about numerical integration, let us talk about what is integration. Okay. In a very simple language, I can say that integration is nothing but finding area under a curve. So when you say integration of from a to b fx dx, so basically what you are doing is you are finding out area under this function fx. And if you want to see graphically, let us say that this is your x-axis, this is your y-axis, and this is your function fx. This is your starting point, this is your ending point. So when you say integration from a to b fx dx, basically what do you mean is the area under this curve. So the question comes at this point is, why do we need numerical integration? So the thing is, in real life, this function is very complicated. Okay. So since it is very complicated, you cannot use the conventional method, the analytical method, to find out the integration of this function. So that is why we need numerical integration. I hope everybody is clear at this point. So that is why we need numerical integration. So when you talk about numerical integration, there are two different methods of finding out numerical integration. The first method is Newton-Cotes method, and second method is Gauss quadrature. Newton-Cotes method is also known as closed integral, and Gauss quadrature is known as open integral. Okay. So the idea behind Newton-Cotes method is basically, again let us take this. Okay. Anyways, I'll discuss it here. So the idea behind Newton-Cotes method is, so we all know, let us say that this is your integration from a to b fx dx. So as I said, when you talk about real life, these function f of x is very complicated and you cannot find integration using analytical method. So that is why we use numerical method. So in Newton-Cotes method, what we do is we replace this f of x by an approximate polynomial. Okay, and we find out the integration of that approximate polynomial. So when you talk about Newton-Cotes method, there are many methods. First method is Trapezoidal method, also known as Trapezoidal Rule. Then is Simpson 1/3 rule. Then there is Simpson 3/8 rule. Then there is Boole's rule. Okay, and the list goes on, it continues. So basically, when you talk about trapezoidal method, what actually we do here is we replace this f of x by a first order polynomial. Okay. So when you talk about trapezoidal method, what we do here is we replace this f of x by a first order polynomial. And when we replace it by a second order polynomial, it is Simpson 1/3 rule. Similarly, when you replace it by a third order polynomial, it is known as Simpson 3/8 rule. And when you replace it by a fourth order polynomial, it's Boole's rule. So in this course, we are just going to study trapezoidal method, Simpson method, and Simpson 3/8 method or 3/8 rule. We are not going to study Boole's rule. If you're curious, you can find out about Boole's rule. Okay. So the idea is very simple. If I'll repeat it again. When you talk about Newton-Cotes method, what actually we do is we replace this complicated function by a polynomial. Okay, and when you replace that polynomial by a first order, replace that complicated function by a first order polynomial, it is known as trapezoidal method. When you replace it by a second order polynomial, it is known as Simpson 1/3 rule. And when you replace it by a third order polynomial, it is known as Simpson 3/8 rule. Okay,